Hello students, this is Mr. Dunaway. Welcome to Chapter 8, Section 1 in the Algebra book. We're talking in this chapter, we're going to begin adding and subtracting polynomials. There's a lot of vocabulary, a lot of which I'll probably cover in class. A little bit you'll see today. Polynomials, we'll talk about that in a few minutes. Easiest thing to do is just jump right into things and get going with some of the review things you're supposed to know. It says tell whether each is an expression or an equation. Well, number one is an expression. So write that in there, and I'll tell you why in a second. Expression. Oops. The reason this is an expression is there is no equal sign. And that's the easiest way to tell the difference between an expression and equation. So number two is an equation. I'll just put EQ, equation, because there is an equal sign. All right, number three, that would be an expression because it does not have an equal sign. And number four is an equation. So simply put, an equation, we are able to solve and find the value of x. An expression, you cannot do this. For example, number three, it says r over 6. Well, it's impossible to solve that for r because it's not set equal to anything. Okay, so expressions, no equal sign. Equations have an equal sign. So number 5 there, true or false question, says expressions with only numbers are always like terms. Expressions with only numbers. Now think about that. That would be like 3 plus 4. Well, would those be like terms? Yeah. So if there's only numbers, then it's true. They would always be a like term because you could add them together. They are exactly the same. Number 6 says an expression can have an equal sign. Well, no, that's what we just said up there. Expression cannot. All right, expression cannot have an equal sign. All right, equations can be true, false, or open. Well, true means that you have a true solution. So that's what it means. It means there's a true solution. All right, false would mean there is no solution. And open means there's many solutions. It basically has a variable. So that's true. Equations can be true, false, or open. Okay, and again, we'll see examples of that as we get moving. It's pretty simple, really, when we get into that in more detail. But moving on down your page, there we see an important definition, an important word called polynomial. Okay. Polynomial. Let's go up to the prefix here. The prefix poly means many or several, and it's used to make compound words like polygon and polynomial. Well, polynomials are forms of expressions, okay, with different types of terms here. Here's an example of a polynomial. All right, notice that these three terms, none of them are like terms. There are no like terms. That's like, L-I-K-E, no like terms. So this is simplified. It's completely simplified all the way down, okay? So 3x squared plus 3xy minus y squared is simplified. In other words, there's nothing we can do to that expression, to this polynomial. All right, so since it has many terms, okay, more than 2, basically we can call it a polynomial. Now there's some more vocabulary that's going to be different types of polynomials, such as this, monomial. Okay, monomials means there's exactly one term. Okay, that's a monomial. So what they're saying here is that 3x squared, that's a monomial. So these are all examples. 3x squared, that's an example of a monomial. There's only one term. Well, how do I know there's only one term? Because there are no plus signs or minus signs. All right, this polynomial up here, see how there's there's a plus and a minus sign? So there's 1, 2, 3 terms in this first one right here. So that one is not a monomial. It's actually called a trinomial. There's 3 terms, trinomial. These are all examples of monomials. So 3xy is a monomial, negative y squared. Those are all monomials. Okay, so again, we're going to talk more about those words because they're pretty important in class. Number 8 down here says a monomial or a sum of monomials is a polynomial. All right, an example might be like 3x plus 2y. All right, you can't add them together because they're different, so it's a polynomial. Now when there's two terms, we can also call that a binomial there. So let's skip these last two right here. They're just looking at other words with the poly prefix. And I'd like to move on to this part that's pretty important on the next page, I believe, for you. It says finding the degree of a monomial. All right, now this gets a little bit confusing later. It's going to be pretty simple for today. But when we're just talking about a monomial, okay, so again, monomial means one term. So you have no plus signs. There's no plus signs or minus. No plus or minus sign. All right, you just have a term like this, like 8xy. That's a monomial because it's only one term. So when you have a monomial, okay, the degree of the monomial can be found by adding the sum of the powers on the exponent. Okay, so to find the degree, you add the sum of the exponents of the variables. Okay, so the degree means, like, here's what they're saying. This is 8. 8. This doesn't have a degree. Okay, 8 doesn't have a degree because it doesn't have an exponent. Okay, but this, or it doesn't have a variable. Okay, I know it's 8 to the power of 1, but since there's not a variable on that 8, all they've done here is they've kind of picked it apart. They're just trying to show you where this comes from. It's actually probably much easier than this sounds. This exponent on the x is a 1. So it's x to the 1, and the exponent on the y is a 1. So what you do is you add those up. 0, 1, 1 added together is 2. That's the degree of this monomial. Okay, so now this only is when you have monomials. Polynomials are a little different. We'll get to that later. So if you're asked to find the degree of monomial, you add the exponents of the variables. Okay, that's what I tried to say right here. Add the sum of the exponents of the variables. There. So the degree of this monomial 8xy is 2. Okay, so let's test it right here. Let's practice it. Number 13, it says, find the degree of each part of these monomials. So here's two different monomials. Here's question 1 and question 2. Question 1, okay, so you have negative 7 times x to the 4th times z to the 1st. Now again, I can't emphasize enough, we're talking about the degree of the monomial. Okay, well, the degree, okay, I'll just put DEG. The degree on the 7 is 0, the degree on the x is 4, and the degree on the z is 1. So if we add those up, this is a 5th degree monomial. Okay, so that is the first question on number 13, a 5th degree monomial. And now let's look at number 11. Well, what is the variable degree on 11? Well, it's 0. Okay, so the answer is just 0. That's a 0 degree right there. So it's about the variable, and you just add them up when you're finding the degree of a monomial. Okay. All right, so that's pushing 9 minutes here. So I'm going to stop this video and start another one for you. So we'll pause here and start up again in a moment.